Good afternoon, this is Schweitzer, and do a quick little review of our test review for bonding in honors chemistry. Alright, so which property is not a property of an ionic compound? Cation, anion is good, high melting points, crystal structures of a bulk crystal dissolves in water. Make sure that we know we can write out an ionic formula that dissolves like this. And of course you want to be able to draw a picture of it showing the cations and the anions, and if we need to include a water molecule, then we also did that as well. So this is one that is incorrect. This ionic solution will conduct electricity across it with these ion particles. That's one property called an electrolyte when dissolved. Bond that shares electron is going to be covalent. Alright, oxygen valence electrons would be 6 valence electrons -2. That is going to be D. NAF, metal, non-metal. This is ionic. An ionic compound is a bond between a metal and a non-metal, which is C. We got, given the opportunity, halogens will form a, well, halogen on the periodic table at the very end, right next to the noble gases. -1. Ionic formula, the first item listed is a metal, magnesium dioxide. Alright, so this is named as a covalent, so we're using our prefixes. That's letter A, magnesium dioxide. Alright, so here we have all these guys, and which one of them has the lowest and highest melting point? Well, the force of attraction is the cation, anion, versus distance squared. Distance matters, but we almost always start off looking at charge difference. We have NaCl +1 -1. We have ALS +3 -2. And then we have magnesium chloride +2 -1. And then we have magnesium sulfide +2 -2. So the lowest charge quantities would be this guy. Highest would be the aluminum sulfide. We go 1, 2, 3, 4. That leaves this as my answer from lowest to highest. The numbers are correlating to the identity of the chemical, just FYI. Alright, so in this case, a little more complicated problem here. All the same concepts. Notice the boiling points here. This is a +1, -1, +2, -2. So yeah, we definitely expect to have a higher melting point of 3600. This question is asking, where would NaCl be? And it'd be very close to this guy. And because the chlorine has a larger radius, again, that distance matters. A larger distance means slightly weaker attractions. Therefore, would actually be just a little lower than NAF, which is letter A. We have number 11, great example of a picture. This is a covalent bond, so this is an intramolecular bond, and this is an intermolecular bond. Great example of a hydrogen bond, to be exact. Therefore, the answer is B. We have a bulk crystal here, which is a classic property of an ionic compound. We have the following substances have highest percent mass. Now, again, in this case, let's say, okay, this guy is 16, all the oxygens are 16, that's the mass of an oxygen atom. But what about the other guy? This guy is 24, this guy is 40, this guy is 87, this guy is like 137, I believe. So, which of these guys has the highest percentage oxygen by mass? It's either this one or this guy, but magnesium is almost half oxygen by mass, which is why it's the answer. I mentioned this one because it's the other end of the spectrum. It's the lowest. Alright, so we have some matching here. Not the easiest here, but right away we want to go through this thing and indicate whether it's ionic or covalent. So this thing is ionic, metal, non-metal, 2 nonmetals, covalent, 2 nonmetals, covalent, 2 nonmetals, covalent, 2 nonmetals, covalent, 2 nonmetals, covalent. Alright, so we only have one ionic compound here. You could probably get a lot of these by process of elimination, but it might be nice just to sketch out the Lewis structure of these guys. So SO2 looks like this. And it has a resonance structure to the other side. We have N2, looks like that. We have O2, looks like double bond. F2 looks like that. And this is just single carbon bonds all the way around. Is a polar molecule, so only the covalents we're looking at here. Contains a stealer. Alright, this guy's got a stealer. Alright, and it looks like it's asymmetrical. So the answer is going to be B. Of course, C has a stealer, but they're both stealers, so it cancels. D, both stealers. E, both stealers. So, and there's no stealers in F, so B is the only one. Contains a resonance structure. In this case, we have, obviously, B is resonating on my picture, but just a kind of heads up, we need to have at least 3 particles, 3 atoms, to order to have 2 bonds present so it can flip back and forth. None of these guys, covalent-wise, have more than 3 items except for B, and F does too, but hydrogen cannot double bond. So there's no option here. Even if it had an extra bond there, we wouldn't be able to do anything in this guy right here. So it is only a single. Let me erase there or not. Anyways, bond contains the most energy. That would be a triple bond, which is nitrogen, letter C. Required humans to breathe. Not a real good question there, but it's oxygen, which is the letter O2, which is the letter D. An ionic compound, okay, well that's A. Most is an organic compound, okay, we did this in chapter 1, that you should label as F as being the organic compound. Most radioactive halogen, there's only one halogen on here, and that's letter E. Has the highest melting point. Ionic compounds are classic for high melting points. That's A. The substance with the highest percent mass oxygen, but not 100%. Well, only one that contains oxygen that's not 100% would be B. D does contain as well, but it's 100%. Okay, in this case, we see 2 substances with pretty high melting points, and the question is why? Well, force equals charge of the cation, charge of the anion divided by the distance squared. That's the large difference of charge here. Alright, names here. So I'll run through these relatively quickly. We have, now remember, ionic compounds need to be charge balanced. So NH4 and then sulfide. This is a -2 plus 1 parentheses 2. Sodium chloride, NaCl. Copper 2 acetate. Copper plus 2 C2H3O2. Bring your ion sheet with you to the test, please. Okay, pentaphosphorus digoxide. This is a covalent compound. It's giving prefixes. Pretty simple. P5O10. Ammonium carbonate. NH4 parentheses 2CO3. Nitrogen pentoxide. O5. Alright, so now we have to flip over to names. Again, you gotta be able to tell what this thing is to use the correct format. This is ionic, so metal, non-metal, metal, polyatomic anion, metal, non-metal, ionic, metal, polyatomic anion, ionic, metal, polyatomic anion, ionic, non-metals around, covalent. Okay, so this is just potassium chloride, and then this is potassium hypochlorite. Sorry for the sloppiness here, I'm in a hurry. This is copper, Roman numeral 1, chloride. This is copper, Roman numeral 1, perchlorate. This is sodium nitrate, Notice that these guys all being ionic never gives quantities. That's just the name of the cation, name of the anion, never gives quantities. This guy is covalent, gives quantities. Carbon tetrachloride. Okay, sulfur dioxide, SO2. We got 6 times 3 is 18 electrons. Sulfur, oxygen, oxygen. 2, 4, 6, 8, 10, 12, 14, 16, 18. Shorter pair. Can you get back here? Erase a pair and share between. And of course, we would need a resonance structure. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Sulfite, SO3 minus 2. Sulfur, oxygen, oxygen, oxygen. That's going to be 6 times 4 is 24 electrons, plus the 2 that are there is 26 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And I add them correctly. I do believe I did. Alright. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay. For some reason I remember there being a double bond there, but if not, that would be the way it would end up. Sulfite. Either way, ammonium, NH4 plus. Just looks like this. Make sure you include a positive 1 charge. Bracket, positive 1 charge. This would be a -2 charge. Alright, moving on to the back page, or getting close, halfway through the back page. Alright, silver chloride, AgCl. This has a mass of 107, this is a mass of 35. This is going to be the percent mass silver would be the mass of the silver divided by total mass times 100. This is 107 divided by 142 times 100 should give you 75%. What is 75% of 25? 75 over 100 equals X over 25 grams, and that would be about 18 grams. Okay, right near the end here, we have a cup, has distilled water, carbonated water, and 3 solutions. Distilled water, a cup of carbonated water, and a cup of table salt. Only one that's going to dissolve would be the table salt, and those are located here. They want us to draw them. Table salt, NaCl, goes to Na plus Cl minus, so make sure we just draw them here separated. And then the carbon dioxide, being covalent, will not break apart, it just stays as CO2. And this is just going to be CO2 floating around in the solution. Being these charged particles here allows electricity to be able to zip across this thing, which is the reason why this one is an electrolyte and will not conduct electricity. So on the previous problem, 3 beakers, the only ones that will conduct electricity, not the distilled water does not, carbonated will not, the table salt water will be a strong electrolyte. And then it just goes on to show the different types and the standards. So either way, that is it.